All right, so here we are on number 5 in section 4.4. So let me write it out for us. 4 minus b is the log of 9c plus 2. Okay, so we're trying to solve that equation. Oh, thank you. I always forget. I have 25 years of not doing that. Okay, so we're trying to solve that one. Now, they want me to solve for c. For c. So it's, it's kind of like keep your eye on the ball kind of thing. This is the ball. So that's the one we're trying to get alone. Kind of keep your eye on the c all the way through. That's the one we're trying to get alone, that little c right there. Okay, so how in the world are we going to get that little c alone? To get that c alone, it's kind of like peeling an onion. You start from the outer layers and work your way in. So to get that c alone, we're going to have to get rid of the log word, and we're going to have to get rid of the 2 and the none, right? And that's clearly the plan. So let's start with the log word. That's the outer layer. How do we get rid of that log word? What do we do to get rid of the log word?
Take base.
What's that?
Base. Take base 10 to the...
Yeah, good. It involves the base. Good. Yeah, that question is the most fundamental one with logs. So let me help you. Let me tell you what not to do, and then let me tell you what to do. So I hope this is like a really important question, right? It is very first one off the bat. A lot of students think, well, get rid of that log. I'll just divide both sides by log. No, don't write that down. That's not right. You can't divide by that log because that log is not multiplied. I know it looks like it is because there's parentheses and everything. Huh? We just think it looks like log times, and just divide it off of there. No. It's not really. You know what that log is? It's actually function notation. It's kind of like saying f of 9c plus 2. But instead of f, it's log. Log is a kind of a function, like f of x or g of x. It's a function. And you couldn't get rid of the f by just dividing, because that's not really times. That's plugged into the toaster is the analogy I always use. A function is like a toaster. So you can't do that. Well, then what do? Use that special rule that I told you last time. Whenever you lose a log, the base stays the base. The other two switch. Let me write that out. Whenever we lose a log, do not divide. You do not divide. That's the mistake. Instead, base stays the base. Other two switch. So that's like the golden rule of logs. I mean, that's the most important rule of logs. That's the most fundamental rule. So so do what you can just to make that rule really sink in deep, because it'll come up in a lot of situations with logs. Is you'll have a log and you'll think, okay, I gotta get rid of that log because I gotta get to the thing inside. So when you do that, remember you can't divide. There's a special thing. You cross out the log. The base stays the base. The other two switch. Now, what do I mean the base? I don't see a base. I don't see a low down number by the G, but there really is, huh? What's really there? 10, right? When it's not showing, it's really a 10. So the 10 stays as the base, and the other two switch. Now, what do I mean by other two? I mean everything else. They swap. The log's gone. He's not there anymore. So that means what else is left? All the 9c plus 2 and all the 4 minus b. They're going to switch positions. Instead of the 10, I wrote in the base by the G there, it's helpful. Instead of looking like 10 to the 9c plus 2, they're going to swap, and it'll be 10 to the 4 minus b, and the 9c plus 2 will go over there. That's the most important step on any log problem, is that right there. Is that good? If you can sink that down deep in your mind and just always know to do that when you cross out a log, that'll help you so much. That's most of it. But the rest is a little more normal things you're used to. That's the weird one. That's the really weird step with logs. So whenever you cross out a log, base stays the base, other two switch. Okay. So now, what are we trying to do? We've got to it's baseball season. All my analogies are going to be baseball, I'm afraid, for the next month. I'm spending hours of my life sitting and watching junior high baseball games. It's baseball season for my son. So anyway, and keep your eye on the ball. So there's the ball. There's the thing we're trying to get alone, right? So what do we do to get him alone now? We can just subtract 2, right? From both sides of the equation. Just gonzo like that. So 9c is 10 to the 4 minus b minus 2. That could just a normal subtract 2 thing there. Nothing more fancy than that. Oops. We good so far? Trying to get C alone. Keep focused on the ball there. Keep your eye on the ball. Get C alone. What do we do to get C alone? Divide by 9, and you just divide the whole thing by 9. Both sides. There it is. C's alone. There's our answer. Kind of a big messy answer, huh? That's it. There's nothing we can do to clean that up. That's got to type that whole thing in there. Is that okay? Questions on that process? Let's kind of run through it again. So I just wrote it out, and they said, C, they want C alone. So I thought, okay, got to lose that log. Whenever you lose a log, that's the main step. It's a special step, just for logs. Logs have a very special step. When you lose a log, base stays the base, the other two switch. Instead of 10 to the 9C plus 2, the 4 minus B takes his place. He's still a base, though. That's the other mistake. I've seen some students, they'll like generally know the switch thing, but they'll put this down on the ground level like that. That's not right. The whole point of being a base is that you have something on you, right? So that 4 minus B's got to be up in the power zone, doesn't it? On that. That's why I say the base stays the base, meaning there's going to be something on him still. So they switch positions, then you just subtract the 2 and divide by the 9. And C's alone. All right, I'll move on if you're okay. Let me give you an overall game plan. This is x in power. Do you notice that? That's called exponential. That's what we call an exponent. Well, yeah, that's the words right. The words right here. That's what we call that. That's what exponential means. In other words, this is not exponential. Because so exponential doesn't just mean there are powers. Like this thing has powers. It doesn't just mean there are powers. It means x itself has climbed into the power zone. Does that make sense? That's why this one's exponential, because x itself, I don't know if you can see it, it's kind of small. X itself, let me write it bigger. X itself is up there. So when x itself climbs into the power zone, that's exponential. That's a different deal. That's a bad deal, right? That's a difficult thing to solve. I mean, do you see the problem? Like how would I, before I write out the steps and everything, how would you do that? Like how would you figure out what x is there? Just think with me for a second before I just give you, step 1, step 2, step 3. It might stick with you better if you tried for a second just to think how you would do it before I give you the steps. How in the world are you going to get that x alone? That's the name of the game, right? Get that x alone. How can we get that thing alone? Yeah, logs would do it. I'm actually going to do it. I'm going to have a way without a log, but there is a way with a log too. Good. Yeah, how did you know logs do it? Because they bring that power down, huh? That's exactly right. That's exactly right. And I'm going to give you 2 ways to do it. So when x is in power, oops, I'm not writing that out very well. When x is in the power zone, there's 2 things. Number 1, try to make the bases the same, then cancel them. If not, log both sides. If not, log both sides. Yeah, so that's the plan when x is in the power zone. You need to really see that. You know what's hard in math a lot of times is we do so many different things. Like we're coming up on an exam next Thursday. We've had a lot of different kinds of problems. And it's hard. You look at a math test and you're like, hey, I did all the homework. I saw the lectures, and I've done a lot of this stuff, but they all kind of look the same. I don't know if it's the power one, the log one, the switch, they all kind of can confuse together. So it's something. So you got to put this in a special category in your mind. X climbing into power. When X climbs into power, that's a big deal, right? I always think, I'm a wannabe history teacher because I spend 1 minute on history. So one of the most famous examples from history that everybody always talks about is Hitler getting into power, right? Hitler had some wacko views, didn't he? He had some crazy views about Jews and about all kinds of crazy stuff. But you know what? There's people today that have those views. They're just not in power, right? That was the problem. The wacko got in power. I'm trying to connect it with the map. So you see that X in power. So let me just do 1 minute of history here. How did Hitler get into power with his wacky views? Was he elected? Let me ask you that question. Did the German people elect Hitler into the vote and he won the election and became the leader? No, he didn't. Do you know? Do you know what
He's a dictator. He was a dictator, considered a dictator.
He was considered a dictator. He was the Führer.
He put himself into power.
Yeah, and do you know how he did it?
I mean, killed someone.
The drugs.
His party was strong. Like,
There's multiple.
He lost the election, actually. He ran for president. He lost the election pretty badly. Somebody else, I mean, there's several people running. They have a multi-party system, and even then they did. And somebody else won, but that person made Hitler the second position, the chancellor, which was nothing at that time. The president was there. You know, the other guy won the presidency. Hitler was running for the presidency with his Nazi party, running for the presidency. Didn't get it, not even close, got 20% of the vote or something, just got wiped away. The president guy won, made Hitler the chancellor, which was still nothing. The chancellor was still way under the president in power. And then there started to be the Red Scare around Germany, meaning things were blowing up all over Germany, and they were saying it was the communists, you know, Stalin and the communists. They called it the Red Scare. Well, we don't know for sure, but it looks like probably it was the Nazi party themselves blowing things up around Germany, made everybody afraid, and so they put a military law on. They passed some laws that said, you know, our country's in danger, the military's in control for a season. Not the politicians, the military. And guess who was in charge of the military during martial law? The chancellor. In fact, Hitler got some laws passed at that time, I don't know how he got it passed, that the chancellor was given absolute control just during martial law, though. Just during the martial law. Well, guess how long martial law lasted? Well, from then on until Hitler died, right? So that's how he did it. He was never elected. He just did this trick with the blowing up. Everybody's scared. They said, oh, we're scared. All right, yeah, let's let that chancellor guy be in control for a while. Anyway, I'm doing too much history. We got to get back to math. So I hope you remember. I just finished 50 hours of Winston Churchill's biography. Fabulous stuff. I love all that time. Can I give you one? This is my favorite scene. You know, Churchill, and there's been movies coming out recently about, anyway, I heard all 50 hours of all the details. He's a stinker, actually. Churchill was hard to get along with, but he's a fabulous leader. The movie will probably portray him as all good. The people around him, they loved him, but they hated him. Like, he was controlling and just thought he was right all the time. But anyway, I'm going to do it too much. This is my favorite scene. Churchill, after, he fought against Hitler, he refused to surrender. He refused to make any deal with Hitler, which he did. That's all true. He was a great and strong leader. And Hitler used to say, I like those Britons, except for Churchill. Hitler literally said that. That was a line from Hitler. Anyway, here's my favorite scene. Once England actually overcame them and was pushing into German territory, Winston Churchill flew his plane to Germany. The war wasn't over yet, but they were pushing into German territory. Russia was as well. And Winston Churchill went to it was the Rhine River that runs through Germany there, and he relieved himself in the Rhine River. He took great pleasure as a schoolboy saying, I'm on your territory, Hitler, and I'm going to the bathroom in your river, buddy. I don't know if that's funny to you, but I thought it was a hilarious moment in history. Churchill thinking, he got him, and he did. It's true. All right, anyway, back to it. That was like 5 minutes of history. All right. So X in power. I do have a math point with that. When you see X in power, think Hitler in power, Stalin in power, whatever. Somebody bad in power. So then remember, okay, that's a special deal. When X gets into power, that's a pretty special deal. We got to do one of these two kind of things. Either make the bases the same. That's the easy way. If you can't do that, then we're going to do the log thing. That's true as well. Can I make these bases the same?
Yes.
Yeah. What can you do with the 4?
2 raised.
Just make it 2 squared. Now, you're not always going to be doing that. If that 4 was a 3, then I couldn't do it. And I would need to do the log of both sides, and I'll show you some of those in a minute. But if they give me a number like 2 and 4, then yeah, I could just make those bases the same, right? And so just make that 2 squared. And then what does it say? Make the bases the same and then cancel them. So in other words, you can just say bye-bye 2's and just say 4x minus 7 the powers must be equal. Why? I don't want that just to be something I tell you. If I told you, hey guys, 2 to some number, I'm not telling you that number, question mark or whatever, is coming out equal to 2 to this other number I'm thinking of. Wouldn't those powers have to be equal? If those powers were different, then how would 2 to one of them equal 2 to the other if they were different? They couldn't be different, huh? Does that make logical sense? If 2 to some power is equaling, if the bases are the same and they're raised to powers and they're coming out equal, well then those powers must be equal too, because 2 to different powers, same bases to different powers, wouldn't be equal, would they? The powers would have to be equal. So once you've made the bases the same, and these things are equal, that the powers must be equal. So you can just cut out the bases effectively. And now this is easy. Why? Why is this easy? X is out of power. So like when Hitler got out of power, it was easy. Once it's not in the power zone anymore. So yeah, I want that fundamental idea to help you think about your solving. The whole problem is when the X is in power. Like I was saying, there's always people with wacky views. The problem is when they get in power. So the problem was that X was in power. Now that X is out of power, so now it's cake, right? Just add the 7, divide by 4, we're done. Once you get it out of power, it's easy. 4x is 9, divide by 4, 9/4. Is that okay? So make the bases the same, cut the bases, then the X is out of power. It's all about the difficulty of X being in power. But once you get it out of power, it's not a problem. Okay, so we're going to use that strategy like 5, 6 problems now. Six to the minus 3x, 1296. Okay, now the question, so there it in, I hope you'll remember the whole thing, X is in power. So when X is in power, you think, okay, that's, first, can we make the bases the same? Can we do that? Well, just use your calculator. I don't expect you to be walking around just knowing off the top of your head, oh yeah, 1296, I know that's 6. But just try stuff. Just try 6 times 6 times 6 times 6 on your calculator. See if you get 1296, or if you go past it, then you know it's not going to work and we'll have to do the log trick instead. But isn't it like 3 of them? Is it 3 of them? Or 4 of them? 4 of them? Oh, it's 4 of them? Okay. Yeah, so 4 of them, and then you go, oh, so that's 6 to the 4th. Makes sense? So I was able, again, these first couple we'll be able to do make the bases the same plan. And then in a minute, we're not going to be able to do that anymore. See how this method's kind of a little hokey? I mean, they had to make that exactly 1296, right? If that was 1295, then this wouldn't work, right? So it's a little bit of a hokey method. But yeah, if you can make the bases the same, great. Normally, you're going to need to do logs. Anyway, so now we can just cut these out, because if they're equal, the powers must be the same. And now X is out of power. Hitler's out of power. It's a piece of cake. Just divide by -3. There we go. Is that good on that? Making sense? When X is in power, make the bases the same. Cut them out. If you can. If not, do log on both sides, which we'll do in a minute. All right, I'll move on. This is also on YouTube. Yeah, that one's a little tricky. Okay, so for that one, let me write it here a little bigger. 3/5 to the x is 125 over 27. Yeah, so the 125, well, I'll start with 27. 27, what multiplied by itself a bunch of times is going to be the 27? It's going to be the 3, huh? So that one I think for sure you'll recognize. 3 times 3 times 3. Anybody know 125? What number goes here? 5. So I would take my calculator, take 5, start multiplying, and you'll find that 5 times 5 times 5 is 125. Okay, what does that mean then? Well, that means I could rewrite that right side as 5/3 to the 3rd power. Does everybody see that? Because it's 3 5s on top and 3 3s on the bottom, isn't it? 5/3, 5/3, 5/3. It's a way of rewriting that. That makes sense. Okay, but bless you. But what about the fact that now what am I supposed to do when X is in power, Hitler's in power? I'm supposed to what? Base is the same, right? That's the first thing you're supposed to try to do, and if that doesn't work, do logs. Are the bases the same? Almost, but they're upside down, huh? They're not quite the same. We gotta make these bases like identical, totally the same, not upside down. So, do you remember any of the rules from algebra about what flips things? Can I flip this one and get it to be the other way? It's negative powers. Negatives in the power zone flip things. Do you remember that rule? Like if you had like 2 to the -1 or something, that flips it to be a half. Or if you have a fraction like 2/7 to the -1, that flips it to be 7 halves. Or if you have 2/7 to the -3, that flips it to be 7 halves to the +3. Does that make sense? The negative part of the power actually flips a fraction or even a whole number. So what that means is if I change that power up there to -3, it'll flip the fraction. So I'm going to go next, I'll flip the fraction and make this -3. See how that became -3 and the fraction flipped? The other side is just sitting there watching. Is that good so far? So anytime you want, if you change the sign on the power, it flips the thing the power's on. And now the bases are the same, aren't they? See how I made the bases totally identical? So now I can just cut them out. Because if 3/5 to something is 3/5 to something else, those powers must be equal. So x is -3, I'm done. There's nothing more to do, right? The powers must be equal. Once you make the bases the same, you know the powers must be equal. Is everybody okay with that? Remember those tricks from algebra, negative power stuff? Questions on that one? Okay, so here we're going to have to do logs. 4 to the x is 19. No way to make bases the same. 19 is not 4 to some power, huh? It's not going to happen. So log both sides and powers down to the front. Remember that third quality of logs, they bring powers down? That's what we want. That's why we do this. So I'm going to put a log on both sides. Like that. Both sides. And then this power. Remember, the whole thing is we got to get that x out of power. That's the problem. Hitler's in power, right? Down it comes. That's that. Remember the three properties we talked about logs last time? The adding, multiplying, subtracting, dividing. And then the third one said powers come down for a log. That's the greatest quality of a log right there, is that powers come down. Like that. And once that x is out of power, remember, that's the whole difficulty. Not that Hitler had crazy views, but they got in power. So the whole difficulty is x in power. So once that x is out of power, you should think, oh, it's easy now. Even though it might look weird, log and all that looks kind of weird, you should be thinking simple, easy steps now, because x is out of power. It's not hard now. And what do I mean? What do you do? Well, this whole log 4, that's just a number. You could get it on your calculator. That's just a number. So, and that's just x times, right? There's no symbol there. So just x times log 4. It's just divide, isn't it? It's just divide by that log 4 and we're done. That's all we got to do. Just that whole log 4. Boom. X is alone. Do they want a, yeah, they want a decimal, huh? So let's type that on your calculator and see what you get. It's going to be 2 point something, I think, right? And they want 4 decimal places. In fact, I'm going to grab my graphing. I should have brought mine with me. My office is just 2 steps away there, so grab it. Walk down. Over log 4. I'm getting 2.12396, and we're supposed to go 4 places. So here's the 4th place. Look, 1 to the right is 6, so that means round up, huh? Whoa, 39 would be 40, wouldn't it? Round 39 up to 40. 2.1240. So yeah, so if we can't make the bases the same, we log both sides and bring the power down. It's just a different way to get the power down. So if you can make the bases the same, do that and cut them out. If you can't make the bases the same, log both sides, bring the power down. That's how you handle Hitler in power. X in power. Good. The algebra will get more messy. Okay. So we have 5 to the x plus 2 is 66. So we can't make those 5 and 6. They're just different bases. No way to make them the same. So right away, log both sides. Cannot make bases the same. Log both sides. So right away, I'm going to say, okay, log of this side, log of that side. That good so far. And then what happens from there? Powers down to the front. So this whole power will come down front, and this power down. Remember, it's dethroning power. It's taking Hitler out of power. So the x plus 2, and you got to put parentheses around it, because that way you don't have to for the other one. Why? If I don't put these parentheses, let me give you a reason. I don't want you to say steps without reason. If I just write it like that with no parentheses, that means only the 2 is being multiplied by the log 5, not the x. Why would that be so wrong? Well, the whole x plus 2 was in power, so the whole x plus 2 becomes a multiplier. So the parentheses make it true to the meaning. So you got to put parentheses. Okay, so we get to there. Now this one's we have a little more algebra steps to do here, don't we? This is a little harder. What do you got to do? Well, whenever you have something up against parentheses, you always distribute. So let's do that. Log 5, boom, boom. We'll go to those two like that. And we'll get x log 5 plus 2 log 5 is x log 6. Yeah, this is going to be a little harder. Everybody good with that first off? So that log 5, in a minute it'll just be a number, but for now we just distribute it like a number. Okay, now the trick, we're trying to solve for x, right? Keep your eye on the ball, so to speak. We got an x here, got an x here. Stay focused on the x. It's all about getting that x alone. The trick is it's in 2 places. What do you do when the x is in 2 places? There's a whole special strategy for that. Let me write that. When x is in 2 places, number 1, get them on the same side. 2, factor out x, like x with parentheses, and divide. So that'd be a good thing to put on your 3x5 card. You get a 3x5. Have I said that clearly? 3x5 card for the exam next Thursday. And that'd be a good one to put on there. Like x in power, the rules. Try to make the bases the same. If not, log both sides. And then x in 2 places. What do? Get them on the same side, factor out, and divide. Okay, so what do I mean get them on the same side? Well, there's 1, 2, 3 terms here. That's how you want to look at it. Pluses and minuses, and of course equals, are separating the things. 3 terms. 2 of them have x's, right? We'll get those guys together at the same time. So just jump this guy over to here. Then both the x's will be on the right side. It doesn't matter right side, left side, whatever. Matters not. Just get all the x terms on one side and all the stuff that doesn't have an x on the other side. Separate out the x stuff from the not x stuff. So what happens when something jumps to the other side of an equal sign? Yeah, you're subtracting it really, huh? The sign changes, correct. So we'll have 2 log 5 equals x log 6 minus x log 5. We good so far? So that x log 5 jumped over, became a minus x log 5. So get them on the same side. Next step, factor out the x. We're trying to get it alone, right? That'll help us get it alone. So now, factor the x out. Remember factoring? It's like reverse distribution, basically. Right? If I was to take this x and redistribute it, it would go right back to the green line, wouldn't it? I just reverse distributed it. That's called factoring. Taking the x out instead of putting the x in. Why do I do that? Because that puts x alone. See how he's alone now? Well, I got to divide, and he'll be totally done. Now just divide by that whole parenthesis, log 6 minus log 5. Divide is our last step here. So divide by log 6 minus log 5. Whatever do to one side, you got to do the other. Boom. X is alone. It's this whole thing right here. Let's get that. They want a calculator number too, so let's get that on our calculator. Really important. If you guys have a calculator, this messes people up a lot, and I don't want it to mess you up. So I'm glad to see so many of you have a calculator with you. Remember, when you're typing this in, parentheses around the numerator and well, it depends. Let me say this. If you have, how are those new ones? Can I grab you? This is for the library, right? Yeah. How are those new ones? Do they do fractions like where they show it like 8? Oh no, it's all flat, huh? Yeah. Okay, yeah. So you guys got to do the rules. Yeah, some of the newer ones like show it like a fraction, and those are great. You don't have to worry about anything. Just type it in. It's all good. But if it's all on one flat line, it looks like those ones are like mine, flat line, then you got to be careful to put parentheses around the numerator and the denominator. So you got to parenthesize this and parenthesize that. Let me go to a fresh screen. So we got 2 log 5 parenthesis divided by log 6 minus log 5. So parenthesis log 6 minus log 5. Does that make sense? So that's how you have to type it in. You must put parentheses around the top and the bottom. Well, not always. When there's more than one thing in the top or the bottom. The reason is because there's a 2 and there's a log 5, and there's 2 logs here. So whenever there's more than one thing in the top or more than one thing in the bottom, you do have to put parentheses, or the calculator will get confused what it's supposed to divide. It'll do something different. Yeah, so always remember that. And same thing for power zone also. Same for 2 items in the power zone. So like if you have 2 to the 3 times 4, you'd have to parenthesize. When you type it in, you have to go 2 to the power, parentheses, 3 times 4. You know what I mean? So whenever you have more than one item in any zone, numerator zone, denominator zone, power zone, whenever you have more than one item in any zone, you have to parenthesize that when you put it in the calculator. That way you tell the calculator, hey, this stuff's all in the same zone. So let's type it in, see what we get. 2 log 5. And watch out, the calculator does its own extra parenthesis for the log, right? So be careful to not get tripped up by those extra parentheses. I'm getting 17.6549. I don't know how far they want me to go. How many places? Thousandth. So now it's 3 places, right? Thousandths. 3 places. So circle the 3rd place and look 1 to the right. Remember how to do the rounding? Whenever they tell you where they want to round to the thousandths. So 1,000 has 3 zeros. That means 3 places. So you circle the 3rd place. This is where you're going to end. Look 1 to the right. If 1 to the right is 5 or more, you go up. So it's going to be 17.655. Are you able to get that in your calculators? On that? Questions I can answer on that? That's good. So more than one item in a zone, numerator, denominator, or power zone, parentheses around it when you type it in on the calculator. Unless you have one of them fancy ones that just shows it all vertical and everything, then that's great. Just type it in as you see it. Good. So everybody good with that solving there? So log on both sides, bring down, right? Log on both sides, bring the powers down to the front. Then I distributed here, and then you had x in 2 places, get them on the same side, factor it out, and divide. A lot of steps. Not easy. Takes some practice. Okay, let's try it. So we have 2 to the 4x plus 2 is 7x. All right, so see if you can go all the way through that thing. Log on both sides, bring the powers down. The whole thing. Doing some steps. Powers come down. Everybody good to there so far? Just log both sides. Hitler's dethroned, take him out of power. And now, remember, log 2 is just a number. It's going to distribute. So we'll get 4x log 2 plus 2 log 2 is x log 7. Everybody good to there? The equal sign, maybe it helped to keep that separation in your mind. So now there's two x terms up there, huh? There's three terms. There's three different pieces. Two of them have x's. So get those two x's on the two terms that have x's on the same side. So I'm going to grab this piece and jump it over here, right? That 4x log 2, just jump it to the other side. Then both the x terms will be on the right side together. Is that good there? Like that? With the two x terms on the same side. And now, remember what you do? You factor it out. You like take it out. It's reverse distribution, basically. That's how we get it alone. Get them on the same side, and then factor it out, and then just divide, huh? Boom. Okay, can you type that whole thing into your calculator? Remember, again, put parentheses around the numerator and parentheses around the denominator. When you type it in, let's see what we get. I'm getting minus, how many do I, 4 places? Okay, minus 1.67694. So 4 places, circle this, look one to the right, so minus 1.6769. Able to get that? Good, yeah.
I'm not positive. I heard the same thing. But
Did you? Yeah, let me see. It's real easy just to do one. There's so many parentheses on these things. 2 by 2, real good. Oh, I can't see.
I think I have log 7 switched around.
Oh. Oh, yeah. Oh, but you got the same exact answer?
Yeah.
Otherwise, oh, yeah, yeah. That's exactly it. Yeah, that's exactly it. Yeah, if you switch the order of subtraction, that changes the sign. That's exactly what it does. Yeah, just like think about 5 minus 3 or 3 minus 5. It's 2 or negative 2. It switches the sign. Yeah, that's exactly it. Good. You guys getting that okay? All is well? Grab me after. I'm glad if you have trouble with the calculator. 10 seconds usually. Help you right after class. Calculator things are super easy. Now, what do you do differently when you have E involved? What kind of a log do you use? ln. That's the only difference. Yeah. So when E, use ln instead of regular log. Because, why do we do that? Because ln of E is just 1. It's real convenient. They just cancel each other out, basically. So that's why. Because ln is the log base E. So that's why that happens. All right. So otherwise it'll be exactly the same. All the rules are the same. So E to the minus 0.94t is 0.33. So how are you, so many things on the test next Thursday. How are you going to, you see that question, how are you going to remember it? Let me help you with it. That's a lot of the battle's identification. What's going to jump off the page there? My whole Hitler story, huh? T's, the letter is in the power zone. So it's still the same kind of problem. I want you to see. Even though E's there, I mean, that's a little bit of the deal, but the main deal is the letter is in the power zone. And you think, oh, the whole Hitler thing, got to get that thing out of power, so take the log of both sides. That's how you think you should go. And they go, oh, it's an E, so I'll do ln of both sides. And that's right. So ln of both sides. So ln, and what happens when we do the log? The whole power comes down to the front, doesn't it? Dethroned. It gets Hitler out of power. That's why it works. That's what Churchill did. He got Hitler out of power. All right, so there we go. And then that ln E piece, that's just 1. So it just vanishes. Which is very nice. Very convenient. That's why we don't do regular log, because then we'd be stuck with that. You actually could. It would be the same answer. It's just not as convenient. It just vanishes. So we just have minus 0.94t is ln 0.33. Good to there. Last step, now we just divide, huh? Now that the t is not in power, it's not a problem. Boom, there it is. I'm going to hit that on your calculator. You know where the ln button is? It's over on the left, just right below the log. I'm getting how many places? I have 4 places. 1.1794. On that. I actually got positive. Because that log on the top, when I hit it, comes out negative over this negative. That's why it's actually positive in the end. Even though you think, yeah, well, that log doesn't. It is that answer to the top comes out negative, even though there's no negative sign. The ln of 0.33 is a negative answer. So in the end, you don't have to know. It just comes out positive in the end. On that, yeah.
So you just put an ln, you don't put the e with it?
Right. You don't need to. Yeah, just ln. Yeah. The e vanished right here because ln of e is 1. Oh, are you saying because base e?
Yeah.
It knows, the calculator knows that automatically.
Okay.
Yeah, good question. Don't need to. Calculator knows it automatically. Yeah. Good. On that. All right, so letter in power. Try to get the bases the same, or log of both sides if the base is e, ln of both. I think, if I don't show them that, they might be confused. But then I won't get to the heart of it. So, all right, let me just do it quick. And it's on YouTube if you want to see it done more slowly. Yeah, this one, the first step is get the base alone. Well, let me just say the first step is to divide by the 2. You just want that 2 out of there. He's just a problem. There, now it's normal. So you don't want like something in front of the base. You want to get the base alone. See what I mean by the base is alone? The E doesn't have anything in front of him now. So that's your first. We didn't have that in any of the other questions. They already were alone. So first divide by 2, get the base alone. So you always want to, if the base has something in front of it or added or subtracted, get rid of that. Now the rest is normal. What now we're saying, okay, X is in power, Hitler's in power, we need a log. E's the base, so it's ln, huh? ln both sides, the power drops down. Like that. Good, ln E, that's 1, it's gone. So this is just 7x plus 7 is ln 4. Now it's easy. The x is not in power. Just jump the 7 to the other side. 7x is ln 4 minus 7 and divide by 7. Boom, there you go. Hit the buttons on your calculator. Remember, put parentheses. You need parentheses. You don't need them on the bottom because there's only one thing on the bottom, but you need them on the top. Parenthesis ln 4 minus 7 divided by 7. I'm getting negative, how many places? 4. 0.80195. Negative 0.80195. So this is the 4th place. Look, 1 to the right. Got to round it up. Negative 8020. Huh? The 19 rounds up to 20. The 19 rounds to 20. 0.8020. Isn't that okay? Negative 0.8020.
Mine keeps saying error.
Oh, there's parentheses around that, right? The calculator automatically does that.
Yeah.
Don't put the 7 in those parentheses. The 7's after. Don't put the 7 in these parentheses,
That's
right? Because that would be taking the natural log of a negative 3, which is what gives you an error. Can't do log of negative numbers. So it's got to be that 7's got to be subtracted outside of that. Good. All right, we better keep. The letter is in power. The letter we want is in power. So A equals capital E, then little e minus PR. Treat the capital E as like a totally different letter than the little e. They're in no way related. Capital E is totally different than little e. Okay, anyway, it's all about, like I tell my Johnny in baseball, keep your eye on the ball. That's all of baseball. What's the ball here? What do we focus on? There's so many letters. Which one do we want? P. It's right here. So that's the one we want. That's the one we have to, in the end, we're going to have him isolated, right? Okay, where is he? It's in power, like Hitler in power. So that's what needs to key your memory on the exam. You saw this exam, you go, oh, letter in power. That's Hitler in power. Log of both sides. Right. That's what you got to do. That's the thinking that you should go through to identify what to do. Now, before I'm not really ready to do log of both sides right now. First, get the base alone. Then ln both sides. What do I mean? Who's the base? When I say base, do you know what I mean by base? I mean this guy. This guy's the base, that little e. Why is he the base? Because he has something on him. This is the base of the table. Why? Because it has a top on it, huh? A base means it has something on it, huh? So the little e is the base. That part has to be alone, just like the last problem. See who was the base here? Again, the little e. The little e had something on him, so he was the base, which means I don't want that 2 there. Get rid of anything outside of the base to get the base alone. Then do the ln both sides. See that same thing here? First get the base alone, then ln both sides. So first get the base alone, then ln both sides. Okay, so how do I do that then? Well, you got to divide off that capital E, don't you? Boom. So we have, that gives us then, capital A over capital E is little e to the minus PR. Good so far? So first get that base alone. So the base is alone now. There's nothing in front of the little e. He's alone. Now natural log both sides. Now's the time. So I'll go, okay, ln. I'll just stick an ln on both sides. That's the greatest thing because it dethrones Hitler. It takes that whole power and brings it down. So minus PR now on the base level, no longer in power. The other side's not doing anything. The other side didn't have any powers, huh? The ln of A over E, there's no powers here. This is just a fraction. No powers. Nobody's going to come to the front because there's no powers on the left side. But the power on the right side is dethroned. He's out of power, isn't he? That's the great quality of the log. Natural log or regular log. Okay, so keep your eye on the ball. Who's the ball? Who are we trying to get alone? This guy. He's saying, I want to be alone. Get rid of all this stuff. Well, ln E, gone. 1. This is 1, huh? So this is just minus PR is ln of A over E. Last step then to get the P alone. Divide by the minus in the R. Divide by minus R. There it is. Oh, did they write it funny? They put the minus 1 over R in the front. Yeah, it's D. So they just stuck it in the front. That's the same thing. Having a minus R divided or putting a minus 1 over R in the front, that's the same thing. You okay with that? You know that's the same thing? Like if I go 1/2 times 7, that's the same thing as 7 over 2, isn't it? Because this is 7 over 1, and that could go to the bottom. Right? So having the minus 1 over R in the front or the minus R in the bottom, same thing. Those are good. Is that good? Questions on that? Some fancy algebra there. Impress your friends with that. That's what I do at social gatherings. Okay, so, log countdown. Did we do some of these? And I called it log countdown? I think. Whenever you have 2 logs, you do log countdown. And what I mean by that, so here, let me bring the question up here. So we've got log base 2 of x plus 3 plus log base 2 x minus 3 is 4. Okay, log countdown. What I mean is I'm going to go 2 logs. Let me change the color up. So I'm going to change this to go 2 logs. Next line is going to have 1 log, and the line after that, no logs. I think I remember talking about that a little bit. So 2 logs, 1 log, no. So that's what you want. So notice how I'm trying to give you tags. I'm constantly trying to give you tags. So when you get to that test and you see this amid the sea of all the other questions, you're like, well, which one's this kind? Is this the base, the power, what is this? Oh, multiple logs. You want to have on your 3x5 card 2 or more logs, log countdown. And put maybe one example of one of these on your 3x5 card, log countdown. So that means you got to go 2 logs, 1 log, no log. Now, how do I go 2 logs, 1 log, no log? How do 2 logs become 1 log? And the base won't change, by the way. That 2 is just like glued to the G, right? That's not going anywhere. What's going to happen? How do 2 logs become 1 log? That was last night's homework. Remember the properties? Remember how adding, multiplying, dividing, subtracting? Remember easier job for 2 people, harder job for 1 person, that whole thing? So adding, an easy job for 2 logs, is going to become a harder job, what? Multiplying for 1 log. See how I went from 2 logs to 1 log and adding became times now? Do you see? Remember, that's the property. That's the first property of the logs. Adding becomes multiplying, and subtraction becomes dividing. If this had been a minus in the middle, which I'll give you one of those too, then I would have written this as x plus 3 over x minus 3. It would have become dividing. So if they have subtraction, you make it dividing. If they have plus, you make it multiplying for 1 log, right? It's the harder operation. Times, that's harder than adding, right? Times is a higher level operation. Harder job for 1 log, easier for 2. Adding for 2. That was last night's homework. That was what that all about. Okay, so that's how we go to 1 log. We do the properties. The properties. That's how we do 1 log. Okay, how do we go to no logs? 2 logs, 1 log. Now next is supposed to play countdown. 2 logs, 1 log, no log. How do you go to no logs? That means I'm going to lose the log. Right. That's the golden rule, right? The golden rule of logs. What happens when you lose a log? I'm expecting a ooh with this one, It just it just sings out of your mouth. Base stays base, other 2 switch. Right, so that's the one you want to know that, like somebody shakes you awake at 4 a.m. How do you lose a log? Base stays base, other 2 switch. You just got to know that one cold. This comes up all the time. So I'm going to lose that log. When you lose 1 log, what happens? Base stays who's the base? The 2. Right, this guy, right? The one that has something on him. The base stays the base. The other 2 switch. What's the other 2? Everything else. All this x stuff and the 4. They're going to switch positions. Instead of 2 to all that x stuff, it's 2 to the 4. And all that x stuff goes over there where the 4 was. That's how you cross out the log. Base stays the base. Other 2 switch. Is that good? Everybody good with those steps? Now we're out of there's no more logs. There's no more logs. So we're out of the logs. We're out of the woods. Sorry, it's a bad pun. We're out of the woods. We're out of the logs. So now we can just solve it like normal. It's not easy. 2 to the 4th is 16. That's just 2 times 2 times 2 times 2. This side FOIL. X squared minus 3x plus 3x minus sign. These cancel. Get to there. There's no more logs, so we can just solve it. How do you solve for x there? Am I going too quick? Want to add that 9 to both sides, bring it over here. So that'll be 25 is x squared. And what do you do now? Square root it. And you're supposed to put plus or minus whenever you square root both sides. I tell my algebra students, if you put a roof on the house, got to go up and down the ladder. That's goofy saying, but try to help them remember. When you put, if I say, I'm going to put a new roof on my house this weekend, I would have to go up and down a ladder, right? And so if you put a root over both sides, you got to go plus or minus up and down the ladder. So that cancels, and that's square root of 25 is just 5, plus or minus 5. But remember that never inside of a log 0 or negative. Remember, you can never have inside of a log 0 or negative. So if you go back to the first step, if you take that negative 5 and you put it right there, negative 5 plus 3, or if you put it in this one, either one doesn't matter. It's going to make either one of those negative, isn't it? So forget it. Forget about the negative. It's only positive 5 is the only answer. You can't make the inside. You must check. You must check on a log to make sure the answer doesn't make the inside of the original negative or 0. Bless you. All right, see what I'm saying? So when you get your two answers, I had two answers at first. I had +5 and -5, but I threw away the -5 because -5 put right here on the original makes the inside of that log -2. It's out. Because you try to calculate, it's error. You can't take the log of a negative number. So it's not really an answer. That was a false, we call that an extraneous root. I won't quiz you on that. It's a false answer. The only answer then is the 5. Is that good? Questions on that one? Yeah, so there's the YouTube. See what I did on there. Are you wanting those word problems? Is that how you're feeling? They're not actually. I'll show you. Though. I'll try to do them quick. I'll get there. What, -3? -3 is a half. Right away, I'd make that half 0.5. We don't need fractions. Make that a decimal. 0.5. Okay. And then what would you do first on this one? Add that 3 over, right? Let's just move that 3 over there. Just get rid of that thing. So we get log base 3 of the square root of 3y squared is 3.5. Good so far? Okay. Now, what do I want to... Basically, when you have logs in there, let me say it this way. When you have logs in there, you want them out of there. I mean, that's pretty much always the plan. So you want to be looking right now and saying, how can I lose that log? So cross it off. What happens? Woo! The golden rule of logs. Base stays the base, other two switch. Right? I hope that's real comfortable for you now. So whenever you got logs, you got to lose them, and that base stays base, other two switch. So who's the base? This 3. The other 2, which means everything else, instead of 3 to that square root stuff, it's 3 to the 3.5, and that square root stuff goes over there. That good to there? Now, let's just leave. It's kind of weird. It's just a number on the left side. It's a weird number. You can get it in a calculator in a minute. But what can you do with the other side? Do you remember your square roots from your algebra days? What can you do with the square root of 3y squared? You know, you can make it square root of 3, square root of y squared. And what's the square root of y squared?
Y.
Yeah. That just becomes regular y. Are you okay with that? So I separated them. The 3 is, the square root is still on the 3. But I separated them, and the square root of y squared is just regular y, right? The root and the square cancel. And now, what do you do to finish solving for y? Now just divide by root 3. Boom. So type this into your calculator. What do they want? Do they want a decimal? What do they want? I guess they want a decimal. I don't know. I better move on to those word problems. So that's the answer. I don't know if they use comma to say there's only one answer on that one. Oh, wait a minute. Oh, it wants plus or minus? It does. Yeah, okay, I went too quick. Okay, it's plus or minus. Let me show you. I see why now. Let me show you real quick. So if you leave, what's the square root of y squared? Well, here, let's do this. Separate these guys like this, right? Separate these. Divide by the square root of 3, so we get to here. Okay, now the square root of y squared, that's going to make this plus or minus. It's the two options. That's a root on it, right? That's a root on it. It's going to make it plus or minus for that y. That's all on that one. So the answers are plus or minus 3 to the 3.5 over root 3. Oh, that's just 27.
Yes,
It's 27. So it's plus or, if you do that in your calculator, does it come out just 27, right?
Yeah.
Yeah, it's plus or minus 27. I didn't realize it, because I kept thinking, where's the decimals? It comes out clean. I didn't realize. Yep, plus or minus 27. So they want you to type in 27, comma, minus 27. That's what they want you to type in. Both answers. Now, you might want to, Mr. Aaron, you said negative's not in a log. Why is that okay here? Because if you plug that in there, see what's going to be done to that negative 27, right? It's going to be squared. It's going to come out positive, so it's okay. The inside of that log is going to be positive, so it's okay. So it's not. So if you heard me say you can't have negative answers for logs, that's not right. You can have negative answers. They cannot make the inside of a log negative. That's what's true. So if I plug that in here, that squaring turns even the negative positive, so it's okay. Both answers are good on that. There's a lot of... Okay, blah, 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 blah. They give me this formula. G of t equals 0.365388 times 1.079188 to the T. Hitler's in power, right? Blah, 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 blah. 1 to 2 trillion, or that's part A, 2 trillion. Well, that means they want me to put this to be 2. Right? So they want you to say 2 equals 0.365388 times 1.079188 to the T. They want me to just stick a 2 there and solve for T. They said when, so T, time. Everybody see what I did there? So how do we solve that for time, for T? Got to get the base alone. Remember, you always have to get the base alone for who's the base? This guy's the base. He's the one that has something on him. He's the base. So you got to first get the base alone, which means divide by that number in front of the base. So divide both sides by the 0.365388. Bonk. And then we get down to here. 1.079188 to the T is 2 over 0.365388. Get to there. And now what? Hitler's in power. Log of both sides. Get him out of power, right? When the letter's in power. And that's just going to be regular log because there's no E anywhere. You could just do ln if you want, by the way. ln would work fine, too. You could do either one. ln's just super convenient when there is an E. You can just use ln all the time if you want. So I'll just, either one. Regular log, ln, either one will work fine. So you do log, some kind of log both sides. Power is dethroned. That's the great quality of the log. Can I go on to the next one? So then you would just, then the T's out of power, you would just divide. Or am I confusing you there? So here, what do we have? We have, so the T would be in the front. You would have T log of 1.079188 over here, log of 2 over 0.365388, right? The T, so last step, just divide by that whole log thing. Just divide by log 1.079188. Same thing on the other side, I just don't have room. Is that okay? On that. Once you get that T out of power, it's ball game over. Just divide. He's out of power. Just divide by whatever's next to him. And you're there. So you have to type all that mess into your calculator. Then part B, same thing. This one you put a 9 here instead of a 2. Is that okay on that? How are we doing? Let's see if I can get one. 23 says this thing is log base 10 of I over I0. That's a Richter scale, how they measure the magnitude of earthquakes. They're saying, okay, blah, 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 amplitude 1 million I0. Well, how do I do that? Right here's the key. I is the amplitude. Amplitude is 1 million I0. Oh, that goes right there for I. So I follow those words. All you really need is when they tell you what the letter is. You can go blah, blah, blah to the rest. But when they say, hey, X is this, or T is that, or I is this, that's when you want to hone in. Oh, I's amplitude. Oh, and you're telling me this is amplitude. Okay, bonk, in for I. So then this becomes log base 10 of 1 million I0. Don't forget the I0, it's there too. Over I0, so these cancel right away, don't they? So then it's just log base 10 of 1 million. And that log base 10, that's just the normal log on your calculator. Hit the button, you'll get a 6. That's a 6 on the Richter scale. That's what that means on that. So I think 24 and 25 are very similar. That's as much as we can do today. So come see me. I'm glad to help you if you have trouble with 24 and 25. So what did we finish? We finished the big, the bad, 4.4 will be due on Thursday.
This is the other one due.
Yeah, so I'll have to bump that. 2.3, I'll move it back. And that'll be due the following Tuesday, 2.3. We'll have to, yeah, it's graphing calculator intensive. 2.3, we're going to do a special thing on Thursday. Make sure you have graphing calculator with you. A whole special program we're going to use on your calculator on Thursday. Good day. Hang on if you got questions, calculator or anything.